August 1967, British Rail Western Region embarked on the construction of a 4-kilometre branch line linking the Gulf Oil Company's refinery at Waterston with the existing Swansea-Milford Haven railway line. Design work was carried out in the new works office of the Chief Civil Engineers Department at Paddington, and 10 months later, 1st of July 1968, the line was opened for traffic. Like all major construction projects, there were physical obstacles to overcome. Local landowners to be placated, and extreme weather conditions which threatened the completion of the project on time. This is the story of how it was done and the team who made it happen.
The junction for the Gulf Oil Refinery branch is approximately 2¼ miles south of Johnston on the Milford Haven line, which was originally a branch of the Great Western Railway South Wales Main Line to its terminus at Neyland, which was closed in 1964 under the beaching cuts. The Gulf branch heads southwards from Harmiston on a long curve across a wide valley, followed by a ridge of high ground near Stainton and a series of smaller valleys and streams before reaching the refinery at Waterston. Topography and land access disputes caused problems with surveying and alignment for the new railway. Stainton Church Tower is visible in most directions, so Eric Richardson, the civil engineer's lead designer, hit on the idea of using it as the principal setting out point. From the church tower, Eric could sight across the disputed land. So with a survey station on the existing railway and another on a scaffold tower on land rented from Percy Davis at Lower Scoverston, he could set out the straight sections of track at the ends of the main curves and fix the final straight to connect with the refinery sidings. Having established the alignment, the design of the earthworks, bridges and other features of the line could now go ahead and the contract be prepared for its construction. The village of Stainton was close to the midway point of the line, so when the construction contract was let in August 1967, the main contractor, Turriff, rented a field on Neyland Road from John James of Barrett's Hill Farm. A site compound was set up for the duration of the contract to provide office accommodation for Turriff's staff and for British Rail's engineers and inspectors, and a mess hut and other facilities for the workmen, a water tower, concrete mixing plant and storage facilities. Work started on building culverts and underbridges. But before the site could be cleared of topsoil, heavy autumn rain set in, making the site almost impassable and seriously delaying the construction programme. As a result, over 20,000 tonnes of topsoil had to be removed from the site. Cooperation with the local farmers was particularly important, and access for them had to be provided by temporary and permanent level crossings, some of which are still used, like this one at Harmiston. The safety of trains on the main line was also a priority, especially with heavy plant working close by. Eventually, when the weather improved early in 1968, Dick Hampton, the earth-moving subcontractor, was able to clear the remaining topsoil and start the major earthworks between Harmiston and Barrett's Hill. Hamptons used two types of bulk excavator. 5 cable-operated scraper boxes, hauled by 35-ton Caterpillar D8 tractors, were used for the heaviest work, and half a dozen Euclid TS14 motor scrapers were employed for longer hauls. Additional D8s were used for rock ripping, push loading and dozing fill. None of these machines were fitted with cabs because Dick Hampton thought they distracted the drivers from their work. It was essential to push load the TS14s in the rock cuttings to avoid wheel spin, which could easily shred a set of tyres at a cost of several £100s. Fully loaded, they could carry 15 cubic metres of spoil at up to 30 miles per hour and discharge their load without stopping. The cumulative effect of bouncing on the high flotation tyres meant that the drivers could only work on them for a few years to avoid internal organ damage. The embankment fill was placed in controlled layers using grading machines to maintain an even profile to the surface. Compaction was achieved by the continuous passage of the earth-moving plant. A boggy area at the bottom of the valley had to be drained before construction of the embankment could start, and by the time it was completed, over 100,000 cubic metres of rock fill had been placed in the 3/4 of a mile between Harmiston and Barrett's Hill. One isolated area of Stainton cutting needed drilling and blasting to loosen the rock. To do this, a pattern of holes is drilled, explosives and detonators placed in the holes using a wooden stemming rod, and the holes packed with sand. Firing cables are connected up and run out to the exploder at a safe distance. At a prearranged time, a warning siren is sounded and the charges are fired. Sometimes at the second attempt. The mudstone in the cuttings was relatively easy to excavate, but the unpredictable slope of the strata meant that an extra 70,000 cubic metres of rock had to be removed from Barrett's Hill cutting and disposed of elsewhere on the site. Barrett's Hill cutting is the deepest on the line, up to 13 metres deep and requiring 124,000 cubic metres of excavation. Because of the lack of usable topsoil, the rock slopes were left bare, except for an initial treatment of sprayed-on hydraulic seeding. But the local gorse soon took over, and 50 years on, the slopes are barely visible. The contractor's ramp into the cutting is still useful for track access. Meanwhile, terrorists were making progress on the bridges over the line. They are all concrete arch bridges, cast in situ, founded on the rock at the sides of the cuttings. The concrete parapet walls and wing walls are faced with artificial stone blockwork. Originally, there were only 3 overbridges needed, one at Barrett's Hill Farm, another to carry Nayland Road at Stainton, and a third at Waterston under the Milford Road. The first job was to create a road diversion round the bridge site, and then excavate down to foundation level and erect the shuttering to form the underside of the arch. Next, the top shutters were prepared and the site made ready for concreting, after a tea break. A long-reach mobile crane and skip were used for placing the arch concrete, which was brought in by ready-mix truck. The concrete was compacted as it was poured using poker vibrators to ensure that no voids or air pockets were left in the arch. Top shutters were needed to contain the concrete where the arch was steepest and had to be fixed as concreting progressed. Each arch was completed in a single pour. The largest at Stainton Bridge was over 130 cubic metres. The crown of the arch was finished off without shuttering, using a specially shaped tamper, and finally trowelled off to give a smooth finish. After the concrete had cured and the arches waterproofed, the wing walls and parapets were constructed and backfilled to road level, and the cutting excavated away underneath. At Waterston, the road was raised by over a metre, whilst at Stainton, provision was made for widening the lane to a full-width carriageway with a verge and footpaths. More problems with unstable rock were encountered at Stainton Bridge. Temporary shoring was quickly installed under the arch, and a system of concrete counterforts was designed on site to underpin the foundation. As a precaution against future rock erosion, the cutting slopes below all the bridge foundations were faced with reinforced concrete and tied back with rock anchors. Things weren't going too well in the cutting through Castlepill Farm and Upper Scoverston, south of Stainton Bridge. Water from springs combined with the constant traffic of machines taking away the extra spoil from widening Barrett's Hill cutting had churned the relatively soft rock into mud and slurry. The material was too soft or liquid to be picked up by the scrapers, so some unconventional loading methods were resorted to, including side-loading traxcavators, back actors, and a face shovel. An additional difficulty was turning the scrapers in the narrow cutting. Dennis Giles, Dick Hampton's foreman, Bob Carter, British Rail resident engineer, and Mike Roach, Terev's agent, go to inspect progress. In spite of all the water problems, the cutting was successfully cleaned out and spread with ballast brought from Bolton Hill Quarry in 14-ton tipper lorries. Their size was limited by the narrow local lanes, and in all, nearly 8,000 tonnes were delivered in over 500 round trips. Efficient drainage has ensured that the cutting is still dry 50 years on. Meanwhile, Hamptons were finishing the earthworks at the Waterston end. By the end of the job, they had moved more than 200,000 cubic metres of excavation. Continuous on-site fuelling and servicing kept the machines working 12 hours a day to maximise production and to catch up on time lost due to wet weather. The deepest cutting was in Roddle Bottom, between Lower Scoveston and Waterston. Much of the condemned spoil and surplus rock was mixed and tipped here, forming an embankment nearly 18 metres high. Cattle creeks for livestock access were constructed on both sides of the valley, and additional excavation was disposed of by widening the embankment for a possible future extension of the passing loop at Waterston, and by reclaiming boggy land on Lower Scoveston Moor for Percy Davis, the farmer. Track laying had already started, working from the main line end, but delays to the earthworks meant that Barrett's Hill Bridge had to be built later than planned without obstructing earth moving or permanent way work. To do this, temporary rails were built into the cutting sides, and special false work on rollers was erected over the track, so that it could be rolled out from under the bridge once the arch was completed. Second-hand permanent way materials, recovered from the Somerset and Dorset line, were delivered to the disused railway sidings at Neyland and brought to the Gulf line by road. Eager Construction's track-laying gang followed closely behind the bottom ballast, which was spread as soon as the drainage was completed. Track laying was labour-intensive. Plant was limited to small tractors, compressors and rail saws. Brawn was the main ingredient, with little concern for sunburn. In 1 month, Eagers had laid 6,500 sleepers, 430 tonnes of rails and 2 turnouts over a length of 2.5 miles, all by hand, using only a few machines and a gang of about 10 men. Top ballast was delivered by British Rail in special dogfish hopper wagons. Unloading the wagons is controlled by British Rail permanent waymen riding on the wagons and by regulating the speed of the train. New Works Inspector Byron Evans supervises unloading the ballast. Close cooperation with Leslie Summons, who had allowed works access through his farmyard at Waterston, was essential to make sure that a level crossing was maintained for farm use on this double-track section of line. After the first lift of top ballast had been run out, the track was adjusted to its final level and alignment by British Rail using track-mounted machines. The tamping machine has a trolley moving in front of it fitted with optical equipment, which measures the level of the track and sends the information to a display in the cab. The operator then adjusts the track to the correct level by lowering the tines of the machine and packing the ballast beneath the sleepers. The lining machine following the tamper has outriggers front and back which measure the curvature of the track. Using hydraulic arms mounted under the machine, the operator moves the track to its correct alignment. Tamping and lining were held up by the removal of the scaffolding used for the rock protection work under Stainton Road Bridge, but the delay was only brief. Late on in the contract, because the owners had failed to agree an exchange of two similar areas of land, British Rail had to provide safe access across the line to the severed properties. Pre-stressed concrete beams for two flat-deck bridges were delivered by British Rail and erected by rail cranes after the track had been laid. At the refinery end, a 450-metre-long passing loop was needed to allow for detaching and reattaching brake vans, which weren't allowed into the refinery because of their solid fuel heating stoves. Approaching the loop, trains were required to stop to detach the van before pulling forward to the refinery entrance. The locomotive then ran round the train via the loop before propelling the empty tankers into the refinery sidings. The van would be reattached to the departing loaded train. When brake vans were eventually dispensed with, Gulf installed their own run-round loop, and the original one fell into disuse. The first oil train ran on the 1st of July 1968, and the Gulf Oil Line continued to carry 1,000-ton tanker trains until the refinery closed in December 1997. During that time, the track was relaid with heavier section rail and new sleepers, but apart from the blossoming of the gorse, little changed. Accommodation works provided under the contract included farm access roads, water supplies and cattle troughs. However, more than 25 acres of farmland were purchased to build the line, 10 acres from Barrett's Hill Farm alone. Richard James, a teenager in the 1960s, son of John James, now farms there, but understandably sees the railway as a waste of land. Other farms which lost land to the line are still run by the same families, among them John Davis at Lower Scalveston and Robbie Summons at Waterston. The Gulf Line has lain dormant since 1997. The connection to the main line and the rest of the track remain intact, but nature is reclaiming its own. Stainton Church Tower is still visible through the undergrowth and beyond modern housing developments. But will there be a future use for the line, or is this the end? The Gulf Oil Branch was constructed in only 10 months, a credit to those who designed and built it. Among them local men Charlie and Dougie Beavis, Penry the T-Boy, Trevor the Site Fitter, foreman Vince Morgan. And British Rail's design engineer Eric Richardson, resident engineers Bob Carter and Dick Watts, inspectors Bill Richards and Byron Evans, tariffs agent Mike Roach, and General Foreman George Neal, Dennis Giles, Dick Hampton's foreman, Eagers agent George Barlow, and many others. Despite the challenges in building the line, not only engineering, but the problems with one or two locals preventing access to the land with shotguns and demanding assistance with the potato harvest, the line was completed on time with good humour and is a testament to the hard work put in by all.